Okay, guys, today we're going to look at the heating curve again, but we're also going to incorporate calculations on the heating curve. So you're going to learn what formulas to use on this heating curve, depending on what phase you're in, if temperature's changing or not. So just let's review over what the heating curve is showing us. So we can see this is a heating curve for water. And we can see that on the y-axis, this is our temperature. It's not listed here, but this is temperature for water. And then on the x is how much heat we're putting in over a certain amount of time. So joules is heat. So if you remember from our heating curve from before, at very low temperatures, we're in the solid state. So if we're looking at water, we're looking at the ice, right? We're looking at solid ice. And as you add in heat going across the X here, you can see the temperature starts to increase and then it flatlines. Remember, when it flatlines is where a phase change is taking place. So the solid is turning into a liquid from B to C. That's called melting. And if I went reverse, again, I'm going to take away heat, take heat away, and then that's going to go from a liquid to a solid. That's called freezing. Now, the starting point of where uh, melting happens is at the very first part where B is located. So it's right here at the very beginning, and then it starts to melt. And once all the ice has melted, the solids turn to all to liquid. Then it's going to be that melting process has stopped, and then the temperature starts to increase. So in this area here, this is our liquid water. Then we flatline again. Starting at D is where evaporation or vaporization is taking place, boiling. So the liquid is turning to a gas. From D to E, it's going from a liquid to a gas. And the opposite, if I take away the energy, take away the heat, I can condense my gas back to a liquid, going from E to D backwards. So this is our phase change. And then again, boiling or evaporation or vaporization starts at point D, right here at the very beginning, and then it ends right here at E. And then when we're at E and up, that's all gas. So that's our steam. All right. So looking at this heating curve, we're going to break it up into 5 parts. Okay. So you should write this down. You might want to pause it right now. Copy this heating curve down. You're going to mark all over it what formulas to use in different parts of the curve. So make sure you pause it and start copying down. All right, so on your curve, we're going to start labeling the different parts. So number 1 is where you have nothing but ice, so solid, right? All solid. And then we're going to label the flat line as number 2. That's our part 2. So when we're melting or freezing, we're talking about part 2 of the curve. And then where it starts to increase, and it's all liquid water, meaning the temperature is increasing. That's part 3. So where liquid water is. Then the next flat line where it says evaporation, condensation, we're going to call that part 4. And where E is, up where steam is, where the temperature starts to rise for all the gas, again, that is going to be 5. Okay. All right. So again, just so you remember, this is my solid. This is my liquid. I'll do L for liquid. And this is my gas. All right. So we are going to focus really on just part 1 and 3 and part 5. We are not going to look at 2 and 4 yet. We'll look at that in the next portion. So just 1, 3, and 5 is what we're looking at. Now, when we're on the curve and we're talking about temperature changes in the problem, you're going to use MCATs for step 1, 3, and 5. If you plot points on that curve, you're going to be using Q equals MCAT. So remember, Q is for heat going in or out of the system. M is the mass of that substance. C is called the specific heat. So again, every substance has their own specific heat. You can look them up on a chart. You can Google it. It's always out there. And then delta T is your change in temperature. So remember, that's final minus the initial temperature. Final minus the initial. All right, so we're going to go on to our first problem and just learning how to plot where everything is. Let me go ahead and get rid of these little notations here. We don't need these right now. So let's go back here. All right, so here's our problem. We want to know how much heat is required to warm 275 grams of water from 76 degrees Celsius to 87 degrees Celsius. So again, you should pause. So you already have your chart written down, numbered where everything is and what the steps, what formulas you're going to use for step 1, 3, and 5. You should write this problem down right now. Pause it right now, write that down. All right. So once you have the problem down, you go back to the heating curve and you plot like where you're starting and where you're going to. So it's telling me that I'm starting with water. So I'm looking at the liquid water right here. And I'm going from 76 degrees Celsius. So like a little point up here is 76 degrees Celsius. And I'm going to 87 degrees Celsius. So I'm increasing my temperature. I'm adding heat in. I want to know how much heat I'm adding in to get that temperature to change. So I know I'm going to have to use MCAT. So I would write that down. And then I fill in things that I know. I know the mass. The mass is 275 grams. I know I'm changing from 76 degrees Celsius to 87 degrees Celsius. So I have to find this change in temperature, delta T, final minus initial. So 87 minus 76. Final temperature minus the initial. That's going to give me 11 degrees Celsius. So I know my delta T now. Now I can always look up the specific heat of water. That's the C part. But I gave it to you in the notes. So you've got it in your notes from last time, so you should have that down. You can always Google it, and then you plug in. So the mass is 275 grams. The specific heat of water is 4.184, and it has joules per gram degrees Celsius times the change in temperature, which is 11 degrees Celsius. Now, all I have to do is multiply all these numbers together. I get about 13,000 joules, just rounding to 13,000 joules. And then I want you to notice, when we take all these units are canceling out here. So let me see if I can, here we go, get my pen. Since I have grams in two places, grams cancel out. And I have degrees Celsius in two places. Degrees Celsius cancel out. That didn't really cancel. There you go. So all I'm left with is joules. So my final unit is going to be in joules. Again, we just rounded to 13,000 joules. All right. So let's try another problem. I have to erase this. Sorry, guys. Let me go here and my eraser because it'll show up. So I'm going to get rid of this. We'll go to the next problem. Again, you want to pause this and write this problem down. So how much heat is required to warm 150 grams of ice from negative 35 degrees Celsius to negative 5 degrees Celsius? Okay, so pause that, write that down. All right, so here we go. You look at your heating curve. Where are you starting on your heating curve and where are you ending? Well, I'm starting at negative 35. So if I were to plot that, that's like way down here, right? Negative 35, because it's below zero. And I'm only going up to negative 5. So I plot my second point. So I'm saying it's about there. So I'm still in the ice section. Okay, but I'm increasing my temperature from negative 35 to negative 5. So I am increasing, I'm adding heat in. So I'm going to use that MCAT formula. Q equals MCAT. I'm going to put the mass in. It's 150 grams of water. And I have a change in temperature of negative 35 to negative 5. Final minus initial. So I do negative 5 minus negative 35. Negative 5 minus negative 35. Remember, a negative and a negative make a positive, right? So basically, I'm taking negative 35. I'm sorry, taking negative 5 and adding 35 to get to that negative 30 degree change. It's a 30-degree change. So basically, if you know you're adding heat in, just take the difference between the two numbers. So 35 minus 5 is going to be 30. I'm adding I'm increasing my temperature 30 degrees Celsius, basically. All right, now I want you to notice MCAP. I'm using specific heat, but I need specific heat of ice. The last time I used a specific heat of water. So I want you to notice on tables, there are different specific heats for different phases. So these are all water, right? Liquid water, solid water, water vapor, which is steam, but they have different specific heat values. So you have to make sure you're using the correct one. Okay. So you're going to grab on to the solid, which is 211. That's going to go in for C. So here's your setup, 150 times 2.11, because I'm using that solid specific heat, and change in temperature is 30. So I just gave you all the numbers here. 9,495 joules is your answer. All right, guys, so let's pause there and try to do a couple more problems before we move on to explaining step 2 and step 4.